Let's start these sessions with the new topics, the adsorption in actions. In these topics, we will see some example how actions of adsorption take place. Take place. In this beakers, we have one beakers. In this beakers, if we put, we in this beakers having gases, different gases like chlorine, N2, NH3, SO2, NO3, H2, NO2, like this. Many etc. gases we having have gases on this beaker. In this beakers, if we add powder charcoal in these beakers, these gases will be adsorbed on the surface of the charcoal because charcoal and pressure is reduced. Pressure will be reduced because what happens in this beaker becomes the pressure will become reduced because of adsorptions of gases on charcoal take place. Charcoal place this. There are no because there how we can see the pressure is reduced. In this because we can see the movement of gases can take place in these beakers. But if we see in these beakers, the the gases can take gases the gases adsorb on the surface of charcoal, and there is no is no movement of gases. It's no movement of gases. In these beakers, we have movement, movement, movement of gases. We having movement of gases. These gases can, these gases can, if we see the movement, if this is the gas, this gas will put pressures on these beakers, side of the beakers, and this gas will become move in these directions. But if we see in these beakers, the powder we adding in this beakers powder charcoals, the gas will become adsorbed on the surface of charcoals, and there is no movement of gases take place. Why this movement of gases was not there? Movement was not there. Movement, why not movement is happening? Because this charcoals, these gases will become adsorbed on the surface of charcoal because adsorptions because adsorptions of gases on charcoal take place. We will see the next example. The next example is, we have one beaker. We have one beakers. We have one beakers. In this beakers, we have solutions of dyne. Solutions of dynes. Solutions of dynes. In other words, we can say methylene blue. Methylene blue. Solution of dye. Solutions of dye. In other way, we can say also methylene blue. These solutions having color blue. This because we have one blue solutions. The name of the solution is The solution is methylene. Methylene blue. We have methylene blue. If we add in these solutions, add powder charcoal, animal charcoal. We add animal. If we add animal charcoal, these solutions will go become colorless. Go become colorless. Solutions go become colorless. Comes colorless. Adsorptions of molecule of dye adsorb on surface of charcoal, and these solutions will go become colorless. This is the one example. It's having color blue. Solutions having color blue. In these solutions we have seen that this solution is colorless. This is colorless. Next, we will see the concept about types of adsorptions. There are two types of adsorptions. The one is physisorptions and physisorptions, and another is chemisorptions. We will see the difference between physisorptions and chemisorptions. The first difference between physisorptions and chemisorption is the physisorptions have van der Waals force between adsorbate and adsorbent. Then we will see the first difference between physisorptions and chemisorption is in physisorptions van der Waals force between adsorbate and adsorbent, and chemisorptions there is a chemical bond. Ionic or covalent. There is chemical bond between adsorbate and adsorbent. Next we will see the second difference between physisorptions and adsorption is in physisorptions it is not specific in natures. Means it is not specific in nature means like physisorptions can make by man, but in chemisorptions it is specific. In chemisorptions it acquires high energy of activations, means activated adsorptions. The next difference, the second difference between physisorptions and chemisorption is it is not specific in natures. It means it doesn't depend on the substance of adsorbate and adsorbent. It doesn't depend on any substance. But in chemisorptions it acquires high energy of activations. It is high specific in nature. It is high specific in nature. Speak in nature. In this second difference, we can see a given surface does not show preference any preference for a gas to be adsorbed be adsorbent adsorbent to be adsorbent. A given surface doesn't show any preference for a gas to be adsorbent. In these chemisoptions, it occurs. If we see in chemisoptions, then it occurs only if chemical bonds are formed. In physioptions, a given surface doesn't show any preference for a gas to be adsorbent, but in chemisoptions it can occur, but there are conditions, there are specific if chemical bonds are formed. The third difference between physioptions and chemisoption is physioption is reversible. Chemisoptions is irreversible. Physioptions can be reversible, but chemisoption is irreversible. It can't be reversed. The fourth difference is between physioptions and chemisoption is in physioptions more adsorptions take place when pressure is increased. In physioptions, the fourth difference is more adsorptions take place when pressure is increased. The fourth difference in chemisoption is it required high energy of activations. It acquires higher energy of activation, higher energy of excitation. If we see physioptions, since it is a exothermic process, low temperature is favorable. Low temperature is favorable. At high temperatures, adsorption decreases. If we see in chemisoptions, high temperature is favorable. temperature is favorable. If we see the graph of physics options and chemistry option is, if we plot graph of chemistry options and physics option is, we plot if we plot graph, this is the graph of physics options. If we plot it, this is the adsorption, this is the adsorptions, in this the temperatures, here is temperatures options. If we increase temperatures, the graph will, the adsorption will decrease like this. Graph will decrease in, this is adsorption, it is adsorptions, it is temperatures. If we temperatures, at higher temperatures the adsorption will occur, and at certain points it will decrease. Certain value, after certain value the adsorption will decrease. There is, in this low temperature is favorable. Temperature is favorable for physics options, but in chemistry options higher temperature is favorable. Next difference between chemistry option and adsorption is, the fifth difference between chemistry options and adsorption is enthalpy of adsorptions. The enthalpy of adsorptions varies from 20 to 40 kg per mole. 4. In chemistry options is 80 to 240 kg per moles. More, the sixth difference is more surface area, more adsorptions, The sixth difference in chemistry option is more surface area, more chemistry options, The seventh difference, between chemistry options and adsorption is, in physics options it is multi-layer. But in chemistry options it is unilayer. These are seven difference between chemistry options and physics options, but they have one similarity is all two are depends on nature of gas. Depend on nature of gas.